continue on with our oil heat discussions, and let's talk about the property of fuel oil. We're going to shift briefly from electrical to some of the mechanical concepts, because as we continue on with our electrical discussion, we have to start involving some of the oil handling characteristics and some of the flame patterns. So fuel oil is the only liquid fuel used for residential and light commercial heating. It's refined from petroleum and it's called a distillate because it's distilled from crude oil. There are 6 fuel oils in common use. You have number 1, 2, 4, 5L, 5H, and 6. All of these fuels vary greatly among one another, but only one is used for residential and light commercial heating, and that's basically number 2 fuel oil. Now, number 2 fuel oil, just so you know, is also sold as diesel fuel, but diesel fuel most often is for on-road diesel, and it is taxable, and sometimes there's some additives, so just be aware. It's good to be aware of the other fuel oils, but you really don't need to do a great amount of knowledge of them for most residential and light commercial work. The properties of oil determines the grade and the reason a particular fuel oil is chosen for an application. Fuel oil is broken down into different properties. They are heating value, carbon-hydrogen contact, flash point, viscosity, carbon residue, water and sediment, pour point, ash content, distillation quality. So the heating value of the oils vary from approximately 135,000 BTUs per gallon for number 1 oil and approximately 153,000 BTUs per gallon for number 6 fuel oil. Number 2 oil has a heating range of 137,000 to 140,000 BTUs per gallon. The 140,000 BTUs per gallon is the number you're most often going to see. So 1 gallon of fuel oil, which is number 2 fuel oil, equals 140,000 BTUs, and that's a relatively important number for anyone who's going to be taking licensing exams. Fuel oils are made up of carbon and hydrogen. A chemical formula tells us the carbon and hydrogen relationship. Number 2 fuel oil, which is home heating oil, contains approximately 85% carbon and 15% hydrogen. The more carbon the oil contains, the greater the heating value is. The higher number of oils, like number 6, may contain 88% carbon. These oils are also called heavy oil because they weigh more than the other oils. So we also have one of the properties, which is the weight of oil. Number 2 oil weighs from about 6.96 to 7.29 pounds per gallon. And number 6 oil weighs about 8.05 to 8.44 pounds per gallon. So it also goes to show that the number 2 oil and the number 6 oil, number 6 has a higher carbon content, it's going to be a heavier oil. The flash point is another such property. The flash point involves the storage and handling of fuel oil. All liquid fuels have a maximum safe storage and handling temperature. The flash point is the lowest temperature at which the vapors above the fuel oil ignite in the air when exposed to flame. The lighter the oil, the lower the flash point, and the lower the maximum storage temperature must be. Viscosity is the thickness of the oil under normal temperatures. This thickness determines the size of the metering device used to govern the amount of fuel flowing to an oil burner. Since the heavier oils are thicker, they require larger metering devices. Viscosity is expressed in Seibolt Universal Viscosity Seconds, SUS, which describes how much oil will drip through a calibrated hole at a certain temperature. As the temperature drops on a certain oil, the thicker it will become, causing the oil to drip through the calibrated hole less and less. Carbon residue is another property of oil. A carbon residue test can be performed on an oil sample by vaporizing a known weight of oil in the process in which oxygen is absent. The remaining carbon residue is measured. If the oil is being burned properly, it will not leave any carbon residue. So again, if we remove oxygen as we burn the oil and we eliminate almost all oxygen, the amount of carbon that's left is the carbon residue. But in normally and properly tuned oil burning furnaces and appliances, we should not have any carbon residue because we should always be giving it proper amount of oxygen. Water and sediment content is another pretty important property of oil. The fuel oil should be refined and delivered with a minimum of water and sediment. Too much sediment plugs up filters and strainers. Water in the oil causes poor flame characteristics and burning problems. It also corrodes the inside of fuel containers and pipelines that are made of steel and iron. We do not want water mixed with our oil. Oil contamination is another property. Corrosion can loosen and get lodged in strainers and filters, and in cold climates it can also freeze and block the flow of oil. Refiners and distributors are responsible for caring for and delivering clean, dry oil. Pour point. Pour point is the lowest temperature at which fuel can be stored and handled. Number 2 fuel oil is one of the lower pour point fuels, which means that it can be used at lower temperatures and stored outside. Heavier fuel oils are more sensitive to cold and become thick when exposed to low temperatures. Now up in the northeast part of the country, they do start mixing some kerosene, which is a number 1 fuel oil, in with the number 2 to lower the pour point for cold winter days. Ash content is the ash content of fuel indicates the amount of non-combustible materials in the fuel. These materials pass through the flame without burning and are contaminants. They can be abrasive and wear down burner components. The refinery is responsible for keeping the ash content within the required tolerances. Distillation quality is another property of oil. Oil must be turned into a vapor before it can be burned. The distillation quality describes the ability of the oil to be vaporized. So the property of oils tell us a lot about the fuel, and we'll be talking more about the properties of oil, specifically viscosity and pour point, as we move through the rest of this course. Again, remember 140,000 BTUs per gallon of oil.